Good morning, students. Today, now we'll be learning on about the assumptions of Huckel's molecular orbital theory. Huckel's molecular orbital theory, or in short, we can represent it as HMO. So, Huckel's molecular orbital theory is dealing with the planar conjugated molecules. That is, molecules which are having alternate double bonds and also having planar and also is planar. So, Huckel's molecular orbital theory is the molecular orbital treatment of planar conjugated molecules. Okay. Now we come to the assumptions of the molecular orbital theory. There is some difference because here we are having conjugated pi bonds, that is alternate pi bonds in alternate positions. So what we are doing is we treat the pi orbitals separately from sigma orbitals. Okay, that is when we write the wave function, we write the wave function as the product of wave function for the sigma orbitals plus wave function for the pi orbitals, psi sigma plus psi pi. Similarly, we calculate the energy as a total energy is equal to energy for the sigma orbitals and energy for the pi orbitals. All the carbon atoms, or how many carbon atoms are there? All the carbon atoms of the system are assumed to be the same. And as you all know, the pi bond, how is a pi bond formed? It is formed by the sidewise overlap of the p orbital. So, in conjugated systems, p orbitals of the carbon atoms undergo sidewise overlap to form pi orbital. Okay. So, the molecular orbital can be expressed as the linear combination of the individual pi orbitals, that is AI1 chi. This symbol is known as chi. AI1 chi1 plus AI2 chi2 plus AI3 chi3 plus etc. AIN chi-n, where psi I is the molecular orbital, ith molecular orbital. Chi-n represents the 2p atomic orbital of the nth electron of the atom. Not nth electron, nth carbon atom. Chi-n represents the 2p atomic orbitals of the nth carbon atom. AIN psi-n means that it is a coefficient of the nth atomic orbital in the ith Huckel's molecular orbital. So we represent the molecular orbital as the linear combination of the individual p orbitals. Okay. Then energy is calculated similarly as EI is equal to, using the variation theorem, integral psi I star h cap psi I d tau by integral psi I star psi I d tau. Okay, so these are the assumptions of molecular orbital theory of Huckel's molecular orbital theory of planar conjugated molecule. So we will be seeing it one by one. We take some examples. For example, first we will take a simpler example, ethylene. Then we will take butadiene. If we know, if we do any one, we can do the others also. So ethylene first, then we'll take the allyl system, then we'll take the butadiene, then finally you have the benzene ring. Okay.